In today's video, we are going to summarize some of the topics that are introduced in section 2.3 related to variables and mathematical operations and assignment. Okay, so it's just an overview of the topics that we're going to see in these notes. And as I said, we will go through about this first half in the video and then finish the next two tomorrow in class. Okay, so for classes that you might have learned about and other languages you might have learned, variables could have been loosely described by just saying, for example, var total. That's how you would do this in JavaScript. Well, Java is more picky, so to speak. Any variable must be declared by specifying the type of information it will hold, then its name. So first, we are going to see the data type, and this right here is expecting an integer. We use int to describe an integer, and then next we see the variable name. Now, we learned the other day about identifier rules, and for variable names, we always start with a lowercase letter. That's our Java naming convention. We can also create multiple variables in one declaration, such as we see here. We can only do that when they are all the same data type. So this first line up here, we've created one integer. Here we have created three integers. None of these integers have a starting value. So they have been created and declared, but they have not been initialized. Now, with Java, we can also give an initial value when it is declared. So in this case, I can go ahead and create a variable called sum, which is essentially a holding place for a value. And in that holding place, I am putting the value of 0. So these two lines of code here have created three integers, and all three of them have starting values. When a variable is referenced in a program, meaning it's used in a line of code, its current value is plugged in, just like how variables are used in math class. Now, assignment. This is essentially when we take a value and we assign it to a variable. And assignment always goes from the right to the left. So whatever expression is on the right is evaluated first. If there is a more complex expression, for example, if it said total equals 55 times 3 minus 7, then all of this would be done first, and then the answer would be stored in total. Any previous value is overwritten, and it's important to note that the data must be consistent with variables declared type. Now, I did put a note here that there are a few exceptions, and we will talk about this at the end of the lesson when we get into casting. But for now, we're not going to get into that. Okay, so let's talk about the different data types that we have. First of all, we have constants, and a constant is just like a variable, except it holds only one value throughout the whole program. Even if we try to change it, the compiler will yell at us. In Java, we use the word final to tell the compiler that we are creating a constant. We also use all caps as a naming convention so that somebody looking at our code would know that that variable value is specifically a constant and cannot be changed. This can be helpful so that values in our program that might otherwise have been confusing are much easier to understand. And let's say the value changes. For example, we've all seen when tax rates change or minimum wage changes. If that constant is defined at the very top of your program, which is best practice for constants, it's very easy to update or change its value. All right, so we've talked about the idea of a variable and a constant, but we haven't really specified what data types we have. In Java, there are 8 primitive data types. And when we say primitive data types, that means that these are the data types that Java provides to us. We don't have to write these. We don't have to do import statements. These are just ready for us to use. Now, of these 8, there are 3 that we are expected to know and use with ease. And that is because these are the ones that are on the AP test. There is int, double, and Boolean. And an int is a value that represents an integer. And an integer has no decimal point available. A floating point number has a decimal point. Now, just because it has a decimal point doesn't mean the value has to have a decimal. So for example, when I talk about possible integers, I could have 4, I could have -10, I could have 1017. When I talk about floating point numbers or doubles, I could have 4.5, -6.7891, or I could have 10. Even though 10 doesn't have a decimal point as part of its value, it can be represented as a floating point by adding on a 0.0. And then we have our Booleans, and Booleans are either true or false, and we'll get into that more in a minute. Now, with this numeric primitive data, you might be wondering, why in the world do we have 4 different versions of these? Why do we have more versions of these? And essentially, the differences of these is how much storage they take up. Now, the two that we need to be familiar with are int and double. And an int is a 32-bit number, and a double is a 64-bit number. The bigger the number, the more places that it can hold. Now, we don't need to memorize this, we don't need to know this, it's just useful information for those of you that might be curious. Okay, let's dive more into Booleans. So a Boolean is a value that represents either a true or a false condition. And it can be used to represent any area where there are two opposite states, such as on and off, yes or no. The reserved words true and false are the only valid values. So a Boolean value can only have the answer of false or true. Now, it is very common when we give Boolean variable names to use things like is done, has discount, is honors, has graduated. By using these is and has, by using those verbs right in front of the descriptor here, then that allows the answer, which is true or false, to essentially answer a question for us. Oops, too many I's in there. Just ignore that one. An example of this is, let's say if I had a Boolean that was just called married. Now, and I said married equals true. Well, you don't know if that means the person wants to be married, if the person is married, if the person is currently getting married today. Whereas if you had the Boolean named is married, then you would know for sure without a doubt with true or false what that value stands for. Now, characters allow us to hold a single character. And a single character can be a lowercase, capital, number, a symbol, punctuation. We'll even see some of these characters where it's more than one value, and that's because this is an escape sequence, which we'll talk, I believe we already talked about those, but we'll refer to them throughout the class. And characters are always delimited by single quotes, which are these guys right there. All right, let's go ahead and move into our arithmetic expressions. So when we're doing our arithmetic here, we are essentially going to see the same arithmetic that we see in math class: addition, subtraction, multiplication, and division. Nothing new here. And the one that usually people haven't always seen before is the remainder operator. And this is also called mod or modulus. And when we work with mod, we are essentially trying to find the remainder after a division occurs. Now, this is an important fact down here at the bottom. If any of the values used in the computation are a decimal number, then the result is automatically a decimal number. Okay, so what do I mean by that? If I were to do 4 plus 7, that is an int plus an int, so my answer would be 11. If I were to do 4.0 plus 7, this is a double plus an int, therefore my answer is a double, and my answer would be 11.0. Okay, so that's just an example of what we mean when we say if either one of the values is a double or a decimal, then the answer will have a decimal. Now, when we are working with this division and remainder arithmetic, we want to think about what happens when we do the division. So if I tried to do 14 divided by 3, first of all, it's not evenly divisible. I would say that 3 goes into 14 4 times with a remainder of 2. So when I am doing the division operator, I want to know how many times that value went into there evenly. So my answer would be 4. if I were doing the same problem with a percent modulator, here I want to know what the remainder is. So I would be interested in the answer of 2. Now, if I look at my next problem, when I'm trying to see how many times does 12 go into 8, that would be like saying I'm trying to make groups of 12 and I only have 8 items. So how many groups of 12 can I make? Well, I can't make any groups of 12. So I have 0 groups of 12 and I have 8 left over waiting to be paired up. So in this case, when I do a division, my answer is the first number, which would be 0. And if I were to do the same problem with modulus, since there are 8 that are still left over, that would be my answer there. Okay, now when we're working with operator precedence, just like with regular math, we are going to do the typical from left to right. We first do multiplication, division, and remainder. Those are all completed first. After that, we do addition, subtraction, and string concatenation, which remember is when we use the plus sign involving characters. And just like with math, we can use parentheses in order to force the way that things are evaluated. Okay, let's go ahead and try the examples on the next slide. Okay, so when I look at this, order of operation says that the division would occur first. Since these are both integers, when I divide, I just look at the whole number. 3 goes into 8 2 whole times, so I have 5 plus 2, both ints, so my answer is an int. The answer is 7. When I look at the next example, both of these are of equal importance. So I do 7 divided by 2, int and int. Answer is 3. 6% 5, what's the remainder? Well, there's 1 left over. Int plus int, my answer is an int. Now when I get to this last example, again, division gets done first. Since the first value is a decimal, when I do this division, my answer will be a decimal. So 6 divided by 4 is 3/2 or 1.5. Since I have a decimal here, I am allowed to keep the decimal. So I would have 1.5 plus 2. And then now I have a double plus an int. So when I add them, I have a double answer. All right, we are going to stop for here today, and we will pick up on slide 15 tomorrow. Have a nice day.